welcome back. So I took a break from calculus for a few days, so I'm coming back now. Today we'll start with one more chapter. Functions we finished, so today we'll do nothing but limits and derivatives. Is the spelling of derivatives correct? I don't know derivative spelling. Derivatives, yes, I'm correct. So before telling any of these, I'll give you a story and tell you actually a brief idea of both of them. Okay, so let's say there is a building. Okay, now there's a ball at the top of the building. You drop the ball with no velocity, just drop the ball. Okay, so if this is the distance s, I'll not say, if it covers like any distance s in, let's say, t seconds, then by physics the formula is that s is nothing but a function of t. S is nothing but a function of t, and it is nothing but at 4.9 t squared. Okay, s is nothing but 4.9 t squared. No need to remember this is just for an example I'm showing. Okay, now if any time the in exam comes, find out the velocity at 2 seconds. Exact velocity, not the average velocity. Okay, how will you do this problem? Because there is acceleration. Okay, how will you do this problem? Now how to do this type of problem is that, like, if you see here, if I draw the graph, look something like this. Okay, let me draw. It will look something like this. Now let's say this is 2 seconds here. You have to tell me the exact speed there. Okay, sorry, velocity there. Now what do I know? What can I do here is I will calculate the average velocity and subtract it. Okay, so let's say the average velocity between 0 and 2 seconds. What is that? That will be nothing but 19.6 minus 0 by 2. What is that? 9.8 meter per second. 1 second. 9.8 meter per second. I'll do a draw table here. If it is from 0, then if it is 0 from 2, then it is becoming 9.8 meter per second. Okay, in the same way, like 0 to 2, if we do 0 to something else like 1 2 1 3, if we do, now if we approach from the left side, like very close these type of values, we can see that the values are coming out to be, if I draw the chart here, this is my time. 1 second. This is my time and this is my velocity that is coming out. If you see 1.5, 1.9, 1.98, 1.99. Okay, 1.5 is coming as 17.15. I have calculated this earlier. 18.62 for 1.9, 1.95. This will be 5. Okay, 1 second. 6. What was this? 6 2. I'll rub this. Okay, so it was 1.95 came was 19.35 and 1.99 it came 19.551. Okay, now if you see from the left side what happened, if we approach from the left side, sorry, right side, like this is t, this is v, for 2.5, 2.1, 2.05, 2.01, 2.5, I think it came 22.05, 2.1 came 20.09, 2.05 came 19.8, 2.01 came 16, sorry not 16, 19.641. So if you can see, if we are approaching from the left, the value is coming, it's going towards 19.6. Now if we approach from the right, you can see it is coming for closer to 19.6. So the value that is very much converging towards 19.6. So I can say at the t is equal to 2 seconds, the velocity will be nothing but 19.6 meter per second. Now this thing I think you will not understand now, the intuitive understanding also. So I will go to limits. When we learn derivatives, I'll again come to this portion and tell you. Okay, so we'll limits. What is limits? Let's say this is an fx equal to x square. If let's say x is tends to 0, what this means it means nothing, it does not, it means something that the value of x is very close to 0 but not 0, very close to 0 but not 0. So now if we see it, what is the graph of x square? It is something like this. Understand? Now let's try to visualize this. Okay, now what is actually limits? What is actually limits? When we center the value of x from both sides to one single value, here 0, then y, if y also gets centered at very small point, that is what we call limit. Meaning what? If I say limit x tends to h, f of x is equal to y, that means what? If this is the graph, I don't know where, whatever the graph may be, let's say this is h. Now if I approach from this side and approach from this side, okay, that means what? For I will take the values of f of x for what? For let's say h minus 0.0001, then h plus 0.00001, like that. So approaching from both sides, if you see this, if you take a value from here, you will see it will yield a f of x here. So if you take a value from here, it will yield a f of x here. So what has now, if we are converging x to one value, that is h here, and it yields another value towards which in y it is converging, then this value is nothing but the limit of this function, limit of this function, that is limit of f of x. This is what limit is. Okay, let me go back to my earlier example, that was this x square. I ask you what is limit x tends to 0 f of x. Now if you see this closely, let's say I will take f of x equal to, this is f of x, this is x. Let's take x equal to 1.1. What is that? 0.001, sorry, 0.01. And if we take now 0.01, it will come out to be what? It will come out to be 0.001. Now if we see, now I'll not do this example, let's change the example. I'll change my example, sorry. F of x equal to x plus 4, for example. I have to find if limit x tends to 0 f of x, what is it? Okay, so now let's say, what is x plus 4 actually look like? It is like this. Okay, this is the function, how it is look like. Now see, let's say f of x and x, let's take values. So let's take the value x tends to 0. Did I give x tends to 0? Yes. So let's take x as value 0.1, so answer comes 4.1. Let's take 0.01, answer comes 0.00. 1. And let's take minus 0.1. There are 3.9. There will be minus 0.01. It will be 3.99. As you can see now, if f of x, like if this is the graph, so as we are converging, let me change the color. As we are a better color. As we are converging x towards 0, okay, y is also getting converged. Y is also getting converged at y equal to 4. You can see that clearly. See, it is getting closer to 4. 3.99. What is lies between 3.9 and 4.01? If you add one more decimal point, it will become 3.99, 4.004. So it is 4 here. It is converging toward 4, as you can see. So what I can say, that limit x tends to 0, f of x is nothing but 4 in this case. Understand this. Now let's take one more function to end it today. Let's say f of x is equal to x less than equal to 0, x greater than 0. Okay, understand this. Now you have to find limit. I think x tends to 0. F of x is what? This is a question. Give 5 seconds. 1, 2, 3, 4, 5. Now, if you have not done, let me draw the graph. If x is less than 0, this is closed. 1 second. The graph will be something like this. Less than 0 is 1, no? So this will be nothing but 1 second. This will nothing be but 1 0, and this will be nothing but minus 1 0. Sorry, it is minus 1 0, and this will be nothing but 2 0. Understand these points? Okay, this okay. Now if you check it out clearly, what am I doing? It's so wrong. 1 second. This will be nothing but this will not be I think I drew the graph wrong. I drew the graph totally wrong. See this will be 0 1, and this will be 0 2. I'm sorry, this should be the graph. Now if we approach from the left hand side, okay, once again let me tell you, limit can be broken into, as you can see, I am approaching from the left side also, right side also. These things are called the left hand limit and the right hand limit. Now if I start from the left, okay, take any value left 0 less than f from left. Okay, as you can see, from the left, if you can go, you'll say it is resulting in 1. See, take x and f of x to be, let's say, minus 0.1, minus 0.01, or minus any such x. That will result in, not x, let me write it y. It will result in what? It will always result in 1 1 1. Okay, so I can say the limit, this is called the left hand limit. Okay, left hand limit, it is written x tends to 0 minus f of x is nothing but 1. Okay, now if you see the right hand limit, okay, right hand limit, now we'll approach from the right. Now x and f of x. What is x and f of x? Let's take it 0.1, 0.001, or any positive value y here, let's say. So what you will get is, it is always 2 2 2. Okay, so y is obviously converging towards 2 here. So limit x tends to 0 plus This is how you write the right hand limits. F of x equal to 2. Now what did I tell you about the limits definition? Remember, limit can exist only if they both converge at a single point. As you can see, if we approach from the, let me change my colors, if we approach from the left, we are getting a value of 1. Okay, now if we approach from, let's say, the right, we are getting a value of 2. So it is not clearly converging at a single point. So we can say that the limit does not exist in this case. Limit does not exist in this case. Understand? Limit does not exist in this case. So if you calculate out left hand limit, and if left hand limit is equal to right hand limit, then only you can say limit exists. If left hand limit is not equal to right hand limit, limit does not exist. Understand this clearly, very clearly understand. So left hand limit, right hand limit, and see, left hand limit is always like this. You'll write it minus on the top and here plus on the top. So actually what you can do, limit x tends to h, f of x is broken actually into two parts. Limit x tends to h minus f of x, limit x tends to h plus f of x. Understand? This is the right hand limit, this is the left hand limit. Understand. Now I'll just give you one sum for the homework, try to do it. Now two sums actually, f of x equal to 3x and f of x equal to, let's say what sum can I give you? F of x is equal to sin x. No, not sin x. I'll not give sin x now. You do 1 by x square. Okay, you try to do, yes, 1 by x. If equal to this, here also x tends to 0, find the limits for each case. Okay, for this x tends to 0 I will give 1, x tends to 1 I will give. Try to do these things and I will solve it the next time. So I'll end it here. So meet you in the next time. So like, share and subscribe to the channel.